Okay, today we're going to be going over all of the area, perimeter, and donut problems related to Chapter 7. And there's a reason why we call these donut problems, and you'll see in just a little bit. Okay, so first off, we want to review a few very important formulas. You need to know and memorize the area, perimeter, and volume equations for each and every common shape. So you're talking about squares, rectangles, circles, triangles. All of this information is in the back of your textbook. So I'd suggest that you actually write this into your notebook so that you have that to reference from. But again, it's something that should be memorized. So please fill in also information for the perimeter and volume. I'm not going to take the time right now to write it in, but make sure to get that into your notebook for tomorrow and for future reference. Okay, so the very first problem I'm actually going to go over is a company relating to pasta. Okay, so this company is looking to design a box for its pasta. Gives you information about specific specs that are required for the dimensions of the box. Okay, so whenever you see a problem like this, the first thing you want to do is to draw a diagram. Okay, this is a box, so we do need to sketch a rectangular prism. And believe it or not, I learned how to draw rectangular prisms from Mr. Ebersol in art class in 6th grade. So you're going to start with a rectangle, since it's a rectangular prism, and I'm going to make my box standing up, so what you see is a nice vertical rectangle. Okay, and you can draw the same shape, just shift it over a little bit. Notice it's the same size, same shape. The only thing I did is I just shifted it up and to the left a little bit. Okay, next thing is you're going to connect the corners, lower left corner with lower left corner, lower right with lower right, and you can make it a dotted line to show some perspective there. Okay, so connecting these lines and these. So roughly this is a sketch of a pasta box. Okay, and we know that if we're talking about volume, that the volume of a rectangular prism is length times width times the height. Okay, rectangular prisms, you're always looking at the area of the base, length times width, times the height. Okay, so if you're looking at this box standing up, here's your length, here's your width, and here's your height. Okay, so always start with a diagram whenever you're given a word problem like this. Okay, so next thing we want to do is to define our variables. Okay, and you said we have length, we have width, and we have height. Okay, so we put this back, make sure that we have the information that we need. Okay, so let's read back into the problem. It says the length is 2 inches more than twice the width. I'm going to write that in right here just so I make sure I have that information. So the length is 2 inches more than twice the width. Twice the width. Okay. And then we also know that the height is 3 inches more than the length. So it looks like in this setup that the only variable that's not really mentioned or is the width. So since we don't have any information on it, that is the variable that we are going to define. So I'm just going to let W represent the width of the box. So now we're going to go back and backfill the information that we have in order to write our expression. Okay, so we know that W equals the width. So when you're talking about the length is 2 more than twice the width. And twice the width, since we're using W, is just 2W. Okay, here we say the height is 3 more than the length. Well, here is our length. to be 3 more, all you're really doing is you're taking your length and you're adding 3. Okay, so here's your length, here's your width, and here's your height. Okay, so writing our expression, we said earlier that volume equals length times width times height. So now it's just a matter of substituting your values in. Okay, so volume equals our length, which is 2 plus 2w, times our width, which is represented by w, times the height, which is, well, 2 plus 3, I can combine that, so I'll put 2w plus 5. Okay, so now it's just a matter of multiplying all of these polynomials together. Okay, let's make sure you see that. Okay, if we wanted to go even further in simplifying this, we can multiply these two first. You would get 2w squared. I'm going to make sure that I write it in descending order, plus 2w. And I'm going to take this now and I'm going to multiply it by 2w plus 5. And you're foiling, and some of you have learned the box method. Some of you like for multiplying vertically. Some people like just multiplying it straight. But I'm going to show you the box method. I'm going to use the box method. You have 2w squared, and then you have a positive 2w here, and a positive 5. Okay, set this up. You should have 4w cubed and 10w squared, 4w squared, and 10w. Okay, so simplifying, you should have 4w cubed, and you know that these are common terms, plus 14w squared, plus 10w. Okay, so the volume would be represented by this expression. Okay, so we might come across an example also. Let's do the next example of just relating to perimeter. So you may be given a diagram of, in this case, a trapezoid, and you know some information like the length of this side, and this side, and then they give you this big P. Okay, this big P, just to make a note, is perimeter. And again, we said perimeter is the distance around an object. So if you want to find the measure of the missing side, what you can do is add up the 3 sides and subtract it from the perimeter. Okay, so I've seen the addition done a number of ways, but I'm going to line it up vertically. Okay, so I'm going to start with, let's see, 6x squared minus 9x plus 3. Okay, I'm going to add 8x squared minus 12x plus 4. Okay, and then I'm going to add the last side, 12x squared minus 18x plus 6. Sometimes it helps to have the barriers. You know, I'm going to add everything together. I will have 26x squared minus, looks like 39x. Actually, yeah, 39x. And then you're also going to have plus 13. Okay. So this is, what this represents is distance from here, if you're traveling, all the way around to this point. Okay, so distance that's known. Okay, so what we want to find right now is the distance of the missing side. So we're going to take our perimeter, and I'm going to use a different color. We're going to take our perimeter, 36x squared minus 54x plus 18. We're going to subtract the distance that we know. okay? And subtracting the distance that we know, I always like to do it vertically or horizontally. We're subtracting this entire distance. So when you do that, remember it's very important to take the whole polynomial in parentheses, okay? And the reason for that is you do need to distribute that negative sign. So you're going to be distributing that negative sign here. You'll have a negative 26x squared, distribute here, plus 39x, distribute here, minus 13. Okay? So now it's just an addition problem. I'm going to go and line up my terms. Line this up, negative 26x squared, took care of that. Line this up, plus 39x. Cross that out, line this up, minus 13. That way I make sure that I have covered every single term and there's nothing left over. Okay, so let's add this up. I will have here 5, a positive 5, and here will be a negative carrying 1, 15x, and 10x squared. Okay, so the measure of the missing side will be represented by this polynomial right here. Okay, so you might also be asked to find the area of that same trapezoid. So if you're still given the information in example 2, you might be asked to find the area. So the area of a trapezoid, if you don't remember it, you can cut it up into pieces. Okay, a trapezoid is represented by the area of a triangle plus the area of a rectangle. Okay, so the area of the triangle, if you're taking a piece just this triangle, looks like there's 1/2 base times height, right? And area of rectangle is just length times width. Well, we know the length and the width of the rectangle, length and the width, and we can go ahead and fill in that information, is 6x squared minus 9x plus 3 times 8x squared minus 12x plus 4. Okay, we know that information. What we don't know here, and let's take a look again, well, we do know the height, but we don't know what the base is. So it looks like so far we can fill in base times the height here is the same distance as the height here, so you have 8x squared minus 12x plus 4. We're going to add these together. But before we do that, we need to figure out what the base is. Okay, so here's our base. Okay, and the base is on this triangle, at least the distance from here to here. We don't know what that value is. However, we do know that the entire distance is this polynomial. We know that halfway, or not really halfway, but this distance here is represented by this polynomial. So technically, if we took this polynomial, subtracted this polynomial, we would get the remaining distance. Okay, so let's take care of that base. Okay, we'll have 12x squared minus 18x plus 6 minus 6x squared minus 9x plus 3. Okay, so we'll have 12x squared minus 18x plus 6. We're going to distribute that negative sign, minus 6x squared, distribute, plus 9x, distribute, minus 3. Let's combine like terms. So minus 6x squared plus 9x minus 6. So you have 3 minus 9x and a negative 4x squared. Okay, so this is your base for the triangle. So basically what we're going to do, if we just want to write an expression, is the area of the trapezoid, area of the, and you can draw in a trapezoid, is represented by the 1/2 times this value, which is the base, times the height, and I'm not going to make you guys multiply this out, but just know that you can simplify it if you would like, plus the length times the width. Okay, 6x squared minus 9x plus 3, 8x squared minus 12x plus 4. So that is your expression for the area of this trapezoid. Okay, so I'm only going to give you one problem, but there are many pieces to the problem to do. If you are given this diagram, I want you to do a number of things. First, find the measure of the missing sides, okay? And just to help you out, this side will be the same as this side, okay? You also want to write an expression to represent the perimeter. And the last thing I want you to do is to create your own word problem to express the area of the donut, okay? So imagine if this was a, I guess a rectangular donut, and it looks like someone took a bite out of it. So you want the area of what is remaining, okay? So I want you to write your own word problem for that. Keep in mind, like the last problem we had, it represented like a company, a pasta company, designing a box. So you do want to get a little creative with that, but also be able to make it believable, make it realistic, and also provide a solution to your problem. Okay, bring this in tomorrow and we will go over it in class. Thank you.